Anyway, the title of this is Design for Construction Safety. It's got a secondary topic, prevention through design. This is a concept that pretty much demonstrates it's one piece of holistic approach to enhancing construction site safety and then future maintenance safety. It was developed by the Design for Construction Safety Work Group within the OSHA Alliance, starting back in 2003. Got put on the back burner for a while. When Obama was elected president, went back to the front burner, but it could never get passed because of the split between the Republicans and the Democrats in the House and Senate. It sort of died for a while under the President Trump, but now with President Biden back in power and the Democrats controlling both the House and Senate, this is moving to the forefront in OSHA and in the Alliance. The roundtable itself is a collection of nonprofit professional organizations, some individual companies, and we'll get into some of those as I get into the program explaining what it is. Recently, President Biden appointed Jim Frederick as OSHA's acting administrator, and he has a long history with labor unions, particularly the United Steelworkers Union, which is one of the real pushers behind the Design for Construction Safety concept. I don't know if he'll be actually nominated for the position permanently, but as of now, he's the acting secretary of OSHA. What he is also is he's also a certified safety professional and has several degrees in safety. Okay, let's see here. Okay, there we go. I guess I gotta watch where I click my mouse. Basically, when we talk about prevention through design, we're talking about several different concepts at the same time. Designing for construction safety is the process of addressing construction site safety and maintenance in the design phase of a project. The customary role, if we think about it, for design professionals is to protect the safety of the public and to comply with the building codes. And sometimes there's a big disconnect when we start talking about the safety codes and the building codes. Another aspect that gets rolled into this whole concept is another program which is called Crime Prevention through Environmental Design. And there are 4 overlapping design principles that are part of the crime prevention through environmental design strategy. You have natural surveillance, which is a placement and design of physical features in order to maximize visibility. You have natural access control, which guides people how they enter and leave a space, whether it's a building, tunnel, or bridge. You have territorial reinforcement, which is the use of physical attributes that express ownership or control of a specific territory. And then you have maintenance and management. And that tactic is related to the facility's pride of place, or what's it trying to portray. Extension of the concept is that territorial concern, social cohesion, and a general sense of security can be reinforced through the development of identity and image of a community. And the CPTED, or the crime prevention, dates back many, many years for this concept, going back to some early discussions on tunnels and bridges. There are many elements that are included in the design for construction safety. I see I missed a letter there. But basically what we're looking at is a means of identifying critical and tunnels through prioritization, risk assessments, vulnerability assessments. This is also a process that was used after 9/11 in considering terrorist attacks and looking at how bridges and tunnels and buildings are protected. basically they want to eliminate military attacks as much as possible. The process is a prioritization of identifying the likely targets with a risk assessment process that are needed to establish a financial scope and to allocate available funds appropriately. There was a blue ribbon panel of FHWA back in 2003 that really looked at these concepts that are identified here and put all these in the order specified. And that has led to a lot of this discussion that's going on now about the design for construction safety. We're going to look at designing for safety, or safety by design, which is improving site safety. And there's been a lot of changes over the last few years as to site safety on construction sites. And a lot of this is handled in the OSHA codes, and we'll talk about that a little later, but it's no longer permissible to just walk through mud to a construction site. It doesn't matter whether it's a bridge, road, or building. And it also identifies how you store material on site to make it a safer construction site. But then we also get into designing for maintenance safety. And that is another whole separate issue that we will talk about. As I said, it's an alliance program. It's very important. This is some of the things we're going to talk about. There's state regulatory effects, there's barriers to this, and there's lots of resources. Just for your information, May is Building Safety Month. And if you look at the 4 weeks of May, you get over to week 4, which is training the next generation. And basically what we're looking at there is actually training them, training builders, training contractors in this whole concept of designing for construction safety. FEMA has awarded over 60 million in mitigation grants just to help develop this whole concept of looking at building codes and how they protect citizens, offices, homes, facilities, schools, roads, bridges, tunnels. Everything is coming into play. And if you look at the one on the right, it's adopting and enforcing public policies to minimize hazard impacts on buildings, infrastructure, and neighborhoods, and to enhance safe construction in high hazard areas. There's a lot of information on workplace fatalities. If we looked at, these are some old statistics that are still being used as a basis for the concept. But John Smallwood showed that 50% of general contractors identified poor design features as affecting safety on the construction site and as affecting future maintenance. A European study published in 1991 found that 60% of accidents and study could have been eliminated or reduced with more thought during the design process. Research in the UK have found that design changes could have reduced likelihood of 47 of 100 construction accidents studied. So there's a real concern for this. And if we look at some of the statistics for work-related fatalities in the United States, we're sitting right around 5,000 annual fatalities yearly, work-related or in the workplace, and over 4.7 million injuries annually that occur in the workplace. Of those, right around 1,000 are related to the construction industry as far as fatalities go, and over 160 are related in civil engineering, and about 70 just in bridge construction. If we look at the 2018 statistics, you can see that it doesn't change much. What is interesting here is if you look at construction managers and first line supervisors, there's a fair number of people who are in supervisory roles that are killed on construction sites. And this is during construction. These numbers in 2019 went up. Construction managers is now close to 150, and first line supervisors in 2019 are close to 130 that were killed on construction sites. Some of these speak for themselves. Laborers, if you think about it, a lot of times they're the people on foot on construction sites. They're getting hit by traffic. They're getting hit by heavy equipment. So, in some respects that you can see where those numbers come from. Roofers from falls. And the list goes on. This is what we call the incident pyramid. And if you start at the bottom, you can see that for every 100,000 hazardous situations, that leads to 10,000 near-miss incidents, which then leads to 1,000 first aid cases, which leads to 100 recordable injuries. That leads to 10 disabling injuries, which leads to 1 fatality. This pyramid pretty much works for all fatalities. You can track it back, and you can find out how many incidents were occurring that were indicators that there was something fatal going to happen eventually. The work-related injury and deaths in the United States from 1992 to 2019 is this graph from a National Safety Council. The blue line shows total deaths. These are just work-related. And the black line shows preventable deaths. And basically what they look at is when they study a fatality is, had we done something different, could it have been totally avoided, or was it just strictly an accident? Safety engineering is a new specialty within the engineering field. It involves architects, engineers, and as was said at the start, I'm a safety engineer. I would routinely draft site-specific safety plans, and for major sites, as we move in SEH into the designing for construction safety. It was something we also had to do for all Department of Defense projects. They required this process already. You might be familiar with the term constructability. That refers to the idea of incorporating construction expertise into the design process to ensure that design is cost-effective and buildable. Designing for construction safety can be viewed as ensuring that constructability review includes the safety aspects of the project. It's important to note that when we talk about designing for construction safety concepts, this only applies to the design of the permanent facility, whatever that is, whether that's a road, a bridge, a building, you name it. And that's only during the total construction aspects of the project. It does not focus on how to make different methods safer, or it does not focus on what the contractor has to do to provide for safety for their employees. It looks at how you can change the design to make it safer to construct. And if we think of fall protection, that's the individual's responsibility to wear it. But what can we do in the design process to make it possible that they can tie off someplace, or to design the project such that they don't have to worry about fall protection? And there are things that we can do. It doesn't address necessarily where you place scaffolding or the type of scaffolding that you have to erect, but it does look at, well, how can we change the process maybe to eliminate the need for it? Design professionals are in a position to make these decisions and to influence the total safety on a construction site. When we talk about risk assessments and vulnerability on projects, we look at a hazard, and a hazard is basically the potential to do harm or damage. Risk, on the other hand, is the product of the probability and the severity. Low probability and a high severity can have the same risk as a high probability and a low severity. And when we talk severity, we're looking at a type of injury, how severe is the injury, and the probability is looking at what's the probability that that is actually going to occur or could occur on this construction project. If we look at just some pictures, I always like showing pictures. How many hazards do we see here? And where's the trench box? You know, you can see a person standing on the edge of the curb over an excavated area that at any time could collapse. In fact, over here, there's actually a crack in the pavement. You got electric lines, you got gas lines, you got water in the trench, lots of hazards, no trench box. What are they trying to do here? Could it be designed such that we don't have to worry about having an excavation like this? What happens when you don't delineate where underground water lines are? You know, I've even got pictures showing what happens when you don't delineate underground gas lines and you hit it with a crane. There's even a residential building code now. And as you can see, this was just a lucky picture. No one was seriously hurt, but they were hurt. And they even tried to tie the ladder off to the chimney over here. But two people on the chimney and a person on the underneath, or two people on the ladder and person underneath, is just a recipe for disaster if you don't know how to do it. And is there an easier way that you could design this to make it safer? A big part of the design for construction safety is also learning how to use your safety equipment. Does anybody know what's wrong with this harness? It's being put on backwards. And proper training should tell them that this has to be in the back of the person between their shoulder blades. So there's a whole lack of training that has occurred. When we look at some designs, this is a very serious incident that happened in Minnesota a few years ago, where they took this girder and it was at the end of the day. And so instead of setting it down or laying it on its side up here on the roadway where they were building the new bridge, they actually set it in place and did not support it. And the girder collapsed during the evening, and this is an SUV that was carrying a family. And the whole family was killed in this incident. The design actually showed them placing the girder like this and did not specify any way to support it if they left it for the evening or for the next day. We also see a lot of things like this where improper equipment is used, whether it's electrical engineering or mechanical engineering or what have you. You know, this is just a disaster waiting to happen. If we talk about scaffolding and cribs on piers for bridges, you know, what is this contraption here? You know, and why do they need it? Can they build this cage out on the ground and then lift it and put it into place rather than having to frame it up inside where the formwork would be? There's many organizations that are involved with OSHA in the Alliance program. This is a list of some of them. You know, American Society of Safety Engineers, American Society of Safety Professionals, Independent Electrical Contractors, International Association of Foundation Drillers, Labor's Health and Safety Found, and there's a lot more, including the U.S. Steelworkers, Mason Contractors Association, National Fire Protection Association, National Institute for Occupational and Health that we know as NIOSH, and the list just goes on and on, all these organizations that are saying we've got to do things differently. We just can't continue to do them in the same fashion that we're currently doing them. Design for construction safety is explicitly considering construction and maintenance safety in the design of the project. And when we say maintenance, we're looking at what happens after the project is complete. And you might have heard some discussion that's been going on in the media talking about the engineer of record or the architect of record. And when they refer to this is the original person that designed whatever that project is. And there's a movement on that if any changes are made to that person's design, that they would then have to be contacted and approve of the change. You know, if you think of the I-35 bridge collapse, how many changes have been made to that structure that eventually led to its collapse. And had those changes gone back to the original engineers, they might have caught the fact that they were going to rip one of the plates. Then we go on to making decisions based in part on the design elements' inherent safety risk. What is the risk? If you look here, this lower picture is in the rotundum of the state capitol. And that is where they have to place the ladder to wash the windows. They could have easily have either made this wider or made some different type of design process in here to make it easier to wash the windows. In the upper picture right above it, placing windows in a new building where they have to reach out over the edge to do it. Safety, constructability, and maintainability is what we're looking at. These are not safe practices. We're looking at integrated design and construction, where the project success requires that the design reflects input from all stakeholders. And when we talk about the timeline as proposed under this concept, we're looking at having everybody take part in the decision-making process, not just the users and occupants, but the facility management personnel, the contractors, having them all get involved right up front to discuss what can we do differently in the design process to make the constructability safer. And safety should be recognized as a design criteria. There are obvious costs, schedules, and quality that will be changed. Everything's talking about sustainability these days, so what can we do in design to make it more sustainable? Part of the concept is even looking at what happens when you have to demolish a structure, whether it's a bridge, tunnel, or building. Can that material be reused? Right now, a lot of building material cannot be reused. Prefabrication is a real emerging process. And safety is also a real emerging issue right now. This is just a schematic timeline, which shows where's the yellow line is the ability to influence the design. And you can see the real ability is right up here at front. And as we go down, the construction starts, costs go up, resources are deployed before you come down, where safety and ability has to be addressed right at the start or during the detailed design process. One of the reasons that this process is so compelling is all safety professionals know that it is much more effective to design safety into a process than it is to try to manage safety within a process. This chart has been adopted from the construction management literature, and the ability to influence safety is on the vertical side, and the project schedule is on the horizontal schedule. And as you can see, if you include construction site safety as a consideration right at the start, you can really influence the design. When we look at it from a different perspective, this is a hierarchy of controls, the prevention through design, where we talk about eliminating the hazard or substituting something in, whether it's material or forms or processes, has to be specified right up front. Because once you get past this, you're getting into the design in phase. And that becomes very difficult to change anything. When safety is not discussed during the design, these are some of the things that can happen. You can see that user occupants can be hurt. The Kansas City Hyatt's is the walkway that collapsed. Luke Brissett is a 10-year-old that he was walking down an aisle at an airport, and a 300-pound slab fell on him and killed him. Designs are unconstructible. I've seen many masonry walls collapse that were not supported or went too high as per the design, which is just prone to fail. Some designs by themselves are hazardous, where there's excavations or high superstructures, not to worry about mechanical, electrical, and plumbing or finishes that can have very hazardous compounds that are used in the process. Some designs are more hazardous, such as installing skylights or access to light bulbs, if we think in gymnasiums and schools. So what can we do to make these a lot safer in the design process? There are economic benefits, and these are just a few. The big one is fewer worker injuries and fatalities, reduce workers' compensation premiums, increase productivity. If you have people that are not hurt, you can work longer. If we look at ASCE, this is from their code of ethics. And you can see that their first canon is hold safety paramount. Engineers shall hold paramount to safety, health, and welfare of the public, and shall strive to comply with the principles of sustainable development, the performance of their professional duties. And then you have the second one, which is engineers shall recognize that the lives, safety, health, and welfare of the general public are dependent upon engineering judgment, decisions, and practices incorporated into structures, machines, products, processes, and devices. And if we look at, let me find it here, NSPE, for those who are professional engineers, the fundamental canons from NSPE, the very first one, under engineers in the fulfillment of their professional duties shall hold paramount to safety, health, and welfare of the public. Then it goes on to rules of practice. Engineers shall hold paramount to safety, health, and welfare of the public. And you scroll down, and it's engineers having knowledge of an alleged violation of this code shall report thereon to appropriate professional bodies and, when relevant, also to public authorities, and cooperate with the proper authorities in furnishing such information or assistance as may be required. It's no longer permissible to just be an engineer or an architect and see something that's unsafe and not do something about it. A typical project arrangement is listed here. All designers agree that the decisions affect cost, quality, and duration of construction projects, but shouldn't designers also recognize that their design decisions affect the inherent risk to the workers constructing the project? There's a principle in quality management that quality must be designed in. This principle also relates to safety, that safety must be designed into a project. In addition, there are practical reasons for each party in a construction project to encourage or participate in this whole concept. And eventually, I have a feeling that under Biden or Harris, that this will be written into the OSHA standards more than it is now. And people that use this process now can market it quite efficiently. So where do design professionals fit in? You basically consider safety issues related to the permanent facility during the design stage and designing out whenever possible anticipated hazards. If we look at just an example here, if we look under IBC paragraph 704.11.1, it says that a parapet wall must be at least 30 inches high. But if you go to the construction standards under OSHA, it requires a 36 to 42 inch guardrail or other parapet for fall protection. If you don't have 36 to 42 inches, then you have to wear or use some other method for fall protection to prevent you from falling. So if the design process had identified a 36 to 42 inch high parapet wall, whether it's on a bridge or a building, then fall protection would not be required. And this also gets into in the maintenance process. because if you do not have 36 to 42 inches, and this is just one of the many examples in the OSHA standards, then every time maintenance is performed, you have to be using fall protection. 1926 is the rules of construction, and this is under OSHA. There's many sections to it, and I could do a whole class just on 1926, or as you see, another book here is 1910, which is general industry. And basically what happens, 1926 builds the project, whatever it is, whether it's a road, bridge, or building, or any other type of structure. And once it's constructed, then it falls under 1910, and these are federal standards. The state of Wisconsin has adopted these standards. The DfCS process may look something like this. You're the owner, the architect, the general contractor, the construction manager, all get together and establish the prevention through design process right at the start. Then you have a 30% design, and for those of us in the design field, this is very common where we go 30, 60, 90 degree, or 90% design areas, and you can see what we're looking at. Finalizing design aspects to facilitate prefabrication, review checklists, perform preliminary hazard analysis, apply multi-attribute decision tools, and then draft erection plans or construction plans, and then review safety constructability of all plans, specs, etc., to make sure that this process is actually constructible. Looking at it in a line diagram, what we're looking at is you have the design kickoff. The key component is the incorporation of site safety knowledge right up front, where it says establish design for safety expectations. The key component is that. There may be limited in scope initially, but as the hazards are identified, you would need to expand to address those hazards. It can be site safety knowledge can be provided by one or more possible sources of information. So using constructability expertise, trade contractors, in-house employees, outside consultants. Many times when I was still working, I'd be called in to review plans or specs, or to even look at the constructability from a safety standpoint of projects. And I can even say that on one project, I saved the general contractor's manager's life, because he was standing behind a pile of material on a bridge deck, and a crane swung a heavy load right behind the same pile. Unfortunately, I was there able to grab him and pull him out of the way. That pile of material should not have been on that bridge. But that was just the way they had for years. That's the way they had done things. OSHA has an outreach program. In the state of Wisconsin, we have an office called Wisconsin Consultation, which will go out to any private sector business, whether it's construction or anything, and will provide safety expertise to them at no charge. There are barriers. When we look at increased designer costs, that itself is a barrier. There will be direct and overhead costs for designers. They're going to have to learn about safety. The project's going to take longer to design. But how do we handle this? Well, maybe we have to educate the owners that total project costs and total project life cycle costs will decrease. If it's easier to maintain, those costs go down. But as it says there, up front, taxpayers may have to pay more. And one of the real problems is when we look at public projects, is a lot of those projects are low-cost projects. And that can be a real issue when we start looking at constructability and safer designs. Because no one wants to pay more. For some reason, it's easier to do on the private side than it is on the public side. Direct costs, each requires more time. It could be spent on other billable work. And for anybody who works for an engineering firm or an architectural firm, you you can only bill out what your billable time. Designers would need safety training. Insurance premiums may rise. And the whole reason there is they're going to be unsure of what liability is that they're accepting. A lot of insurance people that I have talked to do not understand that if we're talking about safety and design, we're not talking about how they construct the project. We're talking about how we design it so it's safer for them to construct. Few design professionals possess safety expertise. UW Whitewater has developed a construction safety curriculum. UW Platteville actually has a safety degree program inside their engineering school. And I think this year they had 125 plus students in that program. If we look at what can happen, this is an example. There's a high voltage power line right here. And the environmental engineer specified the groundwater monitoring wells were to be dug directly underneath the power line. The contractor went out there and dug the holes right underneath the power line, and a person got killed when they contacted the power line. There were things they could have done different. They could have specified the wells be dug in another position away from the overhead power lines. They could have informed the construction company about the power lines. They could have contacted the power company and said, you know, we're going to be doing some work around the lines. Maybe they could come out and shield the lines. And there's lots of examples like this of things that have happened that they could do differently. These are some examples of prefabrication. Prefabricated stairs, and then you have a prefabricated platform so you don't have to use ladders. Or tip-up construction, and if you're familiar with the Middleton Fire Station and other buildings in the area that Newcomb has put up, they use a lot of tip-up construction. You build it on the ground, you tip it up. Segmental bridges, the same thing, where you're building stuff on the ground where it's safer, and then you're lifting it into place. It's a much safer process that reduces the hazards associated with working at heights. Just threw this one in for the fun of it, but it's a nice example of what happens on construction projects. Wearing a safety vest, wearing his harness, wearing his lanyard, and what's it tied off to? You know, if he's working that close to the edge, you're within 6 foot of the edge of a fall hazard, you have to be tied off. If he fell, you know, that lanyard's not going to do him any good, and neither is the harness. But there are things we can do on construction projects. These are, the lower two are designed in tie-off points and systems so that when you go up and you do maintenance, all you have to do is tie off. The one on the lower left is window washers, and this whole system exists so they have pre-designed points that they can use. Here's one for inside for lifting equipment and working at heights. Some of you may have seen this picture. This is from a very famous Wisconsin landmark. This is at Lambeau Field. And the guy stepped left instead of stepping right. And fortunately, he was wearing a harness and a lanyard. But he was up there for 15 minutes before they could get him down. But when we talk about body wear, which is basically your harness with your lanyard tied off someplace, it has to go to a beam that is designed to hold 5,000 pounds of shock pressure. Here's a tie-off that's built into a building. Here's one in a roof. These are all things that can be done for fall protection. Residential construction is no different. The tie-off points are very important even in residential construction, and there's now a residential building code that addresses a lot of fall hazards and actually even addresses the excavation next to foundations when they're putting in the foundation walls. But there are solutions that exist for fall protection, solutions that exist for other safety features too. If we look for the structural steel design manual, if you look at a detailing guide for the enhancement of erection safety, there's a lot of new safety items that are specified for steel erection. Here's a very good manual. It's down here in the lower left that shows the detailing guide for steel erection. And there's a lot of changes in the steel erection. And what we have here is we have holes pre-drilled in the vertical members for steel guardrail, steel cable guardrail that works as a fall arrest system where they can hook your lanyard onto. They already exist. You can specify shop welded connections instead of bolted connections. You can specify dimensions of connections. And here's showing the use of those holes. These were points that were determined in the design process where it was safe to place these cables so they could use it and put their lanyards on it. And also locating the splices at an elevation where you're not reaching overhead, but we're working no higher than shoulder height for the connections. I always like showing this one, which provide enough space for making connections. I was working on, I think it was Tower Drive, although it might have been the Arrowhead Bridge tied arch many years ago in my early years. And on the design team, we had a couple other engineers, and we were arguing over the constructability of some connections. And those are big box beams that are on the tied arches. And two of us were saying, there's absolutely no way you can make that connection. And they were saying, yeah, yes, there is. We constructed out of cardboard, full scale, those connections to prove to them that it was not possible to make the connections as designed. And that was really eye-opening for them, and that actually led for us having the capability to put our signatures on all of the three major tied arches in the state of Wisconsin. Know the dimensions of tools that are needed to make connections. They say they need a wrench, but look how long some of these wrenches are. They just will not fit every place. Prefabrication, which is the link between environmental sustainability and safety. Prefabricated construction is safer than stick built. We all know that. Work is shifted from dangerous work environments down to the ground. And we're no longer working at heights. You're not in trenches. Everything's built on the ground. And if you can eliminate confined spaces and exposure to weather, that's even better. Prefabricated construction has lower construction waste, lower embodied energy loss and use, and lower creation of greenhouse gases. And if you ever talk to Brett Newcomb from Newcomb Construction, you'd find out that that's one of the reasons they do tilt-up construction, is it's very little waste with it. You're building it exactly what you need. Whoa. What we have here is other prefabrication, bridge trusses, concrete wall panels, pre-engineered buildings, everything built on the ground, or segmental bridges. A lot of pedestrian bridges are built like this nowadays, and even some highway bridges. Not so much in Wisconsin, but in a lot of other states. Things we can do to skylights, it doesn't really affect the appearance of a building with skylights if you build a curb around them or put steel mesh coverings on them so you can't fall through them. And this is an easy solution. Or putting up parapets on buildings that are 36 to 42 inches high so you don't have the possibility to fall off the roof. Parapet roofs generally in the past have not been designed that high, but that would be a good practice, and that is in the OSHA standards now. If you design upper story windows that are 39 inches above the finished floor, all of a sudden you no longer have to worry about maintenance workers when they're working inside falling, because that height works as fall protection alternative. What else can we do? We can design underground utilities using trenchless technology. A lot of underground utility workers do that now. We can specify primers, sealers, and other coatings that do not emit noxious fumes. Design cable type lifeline systems for storage towers. Putting cages around water towers and antennas that where people have to climb, so it's safer to climb. These are cast in place sockets for railings. So you have something you can put in temporarily, and then when the construction is done, you have a place where you can put the finished stairs railings. These are tilt up brackets that are designed in. They tip forward when there's no pellet being put up there, and then after the pellet's up there, now that it could tip down and it opens on the other side. So you do not have this opening in the railing where someone could fall through or step off of. If you look at this, maintenance access, whether it's the atrium lightings or wherever, this is the vehicle they generally use as a man lift. Well, look at the doorway he has to get through, where they want to store it. Yeah, if any of you have seen that one joke where a guy gets driving down the road and hits his head, that's exactly what would happen here. You make the doorway higher, find out what equipment they're using, and you can design it safer. There's four, as we call them, trajectories: increased prefabrication, increase the use of less hazardous materials and systems, increase application of construction engineering, increase spatial investigation and consideration. It's gaining ground. It's been required in England and Europe since 1995. It's required in lots of other countries right now. The Design for Construction Safety Work Group in OSHA has been working on this concept since 2005. NIOSH has a Prevention Through Design workshop with lots of funding available. ANSI standards and technical reports are now addressing this concept, and it's really moving forward. I think eventually it will be required in all projects in the United States. For those that try to get LEED certification, there's credits available now for using design for construction safety. There's lots of resources. This is just some of them. If you do type in design for construction safety or prevention through design or crime prevention through design, you'll find more information on the internet than you ever wanted. Some things to pay attention to when we look at what has happened. You go over in Asia in particular, if a building collapses or a bridge collapses, what happens to the design engineer or the design architect? Sometimes they just plain disappear. If someone dies in one of their projects, they pay for it. There's a safety certification process for transportation project professionals. This is through the American Road and Transportation Builders Association. And this is some explanation on putting safety first. Because as custodians of the public's tax dollars and trusts, project safety is the top priority for transportation agencies and your personnel. It just goes on. It shows your employees that project safety is the agency's top priority. And having professionally certified personnel on all stages of a project from inception through completion should help reduce safety incidents. And if we look at the top four, or what OSHA calls the fatal four, you see why they have this certification. 60% of all fatalities in construction occur in the following 4 categories: falls, which is number 1, struck by, electrical, or caught in between. And caught in between is between pieces of equipment, between pieces of material, or almost anything. But falls, interestingly enough, is number 1. It has been for a number of years. Likewise, the most fatal falls occur at low elevation, less than 19 inches. So it's not necessarily just the high falls that kill people. Hazard identification. This is what a design for construction safety review should include. What construction safety hazards does the design create? Have you done a risk assessment? What is the level of safety and health risk associated with each hazard, and what level of hazard or what level of risk are you willing to take? Obviously, if it's on a high bridge, you're probably not going to be willing to take very much risk. If it's a very low elevation, you might be willing to take more of a risk. What can be done to reduce the risk? And remember the hierarchy. Designers have a fear. The fear is undeserved liability for worker safety. But we're not talking about being responsible for the worker safety. We're talking about the design. We clearly have to communicate that we are not suggesting that the designer should be held responsible for construction accidents. We need to develop revised model contract language to identify this, and it already is existing in many contracts. And propose legislation to facilitate design for construction safety. Well, that's already occurring. It's being introduced in the House. How long it will take, or if it'll ever get out of the committee, I have no idea. What it is not is it is not having designers take a role in construction safety during construction, unless they are hired as a construction manager, or if they have some role on the construction project. And then it's, if you see something, you have to say something. It's not an endorsement in any way of future legislation or the principle that designers can or should be held responsible for construction accidents. It is not implying that the vast majority of U.S. design professionals are currently equipped to design for construction safety, because many are not. There's not many of us that are certified as safety professionals or have safety engineering degrees. We're just starting to get more people into construction safety in Wisconsin through UW-Platteville and UW-Whitewater. Architects have a fear of liability, and they even have it in one of their documents, where the architect shall not have control over, charge of, or responsibility for the construction means, methods, techniques, sequencing, et cetera, et cetera. What is interesting is that paragraph is in the construction services section and not in the design services section. And like it says there, we need to talk about safety during design. Drawings, tech specs, and constructability discussion with the owners are always at least implicitly involve means and methods discussion. So we are talking about it. We just don't want to admit that that's what we're actually doing. It does spur success and collaboration. OSHA is now collaborating with NIOSH on several roundtables on this. NIOSH and NORA Construction Sector Council have developed a design for construction safety work group. NIOSH Prevention Through Design National Workshops started in July of 2007, and they've now been holding one every year since. This is just an example of one of the checklists, and just part of a checklist, just showing what is involved. And you can see that really, just stuff that is put into the design, whether it's for framing or accessibility, that it makes the project safer. And like I wish when I was doing building inspections, some of these had been in place years ago, such as locating shutoff valves and switches in sight of equipment. Because when I did do stuff for the fire department, it seems that the switches are never where you want them. We are using tools nowadays, BIM for visualization of project, whether it's roads and highways. It was used very effectively on both the interstate construction and Verona Road to show neighborhood groups what it was going to look like. It's used in building construction to show what buildings look like. And in summary, design for safety can improve safety and health on construction sites. Many countries require or promote designing for safety. Just a question of time before the United States gets this as mandatory. National organizations are working to create tools, eliminate barriers, and facilitate adoption of this process. Construction is hazardous. It's hazardous for any entity involved in a project, and to reject the possibility of contributing to a safer job site should not be in our deck of cards. And this includes architects and engineers. They have to pay attention to what they're designing and how it affects the constructability and the safer constructability of a project. Very interestingly, today, an article came out from NSPE, and if anybody is interested, I can send this link to them. But it basically is talking about what is happening in engineering, what is happening in licensure, and what is going to happen for future bridge engineering. And there's already quite a move on to have a 2-year associate's degree qualify to take the PE exam and be licensed. And to a lot of us, that is not the way we should be going. 2 years, you do not learn a lot of stuff. And an associate degree or even an engineering technician degree should not be a guideline for licensure. There are some things we cannot prevent. And this is the finished product of an accident. To let you know what happened over here, this sort of the blow up, you see where the guardrail's down? This truck went airborne and ended up right where you see it, pointed the opposite direction. There's a passenger still in the vehicle. The driver's down here on the apron. No matter what we do, we're not going to be able to prevent accidents like this unless we literally put an 8-foot wall. And even then, I've seen stock cars go over an 8-foot wall. So not much we can do, but there are things we can do in the construction for safety. Look forward to any questions you might have.
Thank you, Norm. I guess if anyone has a question, just unmute yourself and go ahead and ask.
Well, I will ask one. Norm, you mentioned a bunch of government agencies that are involved, like OSHA, for example, that pushes for this. But how about the insurance industry? It would seem like the insurance companies would have a vested interest in seeing to it that these designs are done the correct way.
The insurance industry, interestingly, is a mixed bag. You got some very forward-thinking ones that see that this is a reduction in risk, and you have those that all they do is see the word safety and panic. And that's going to be an issue that's going to take time to address. The overall concept is that it will make for a safer project. It'll, even though some people are saying, well, it makes designers more responsible, but it does not make them more liable. Basically, I mean, I mentioned, you go over to some of these other countries, particularly in Asia, and you have a project fail, you're killed. we're not, I don't see us ever going, hopefully, that route. But I think there are benefits to it, particularly when you see that if we have a designer of record and you're making a change to his design, that you should go back to him and make sure it's a viable change that's not going to deteriorate the project. I-35 is a good example of what can go wrong. The recent bridge collapse in Florida is another example of changes that were made after the design where something happened. We need to pay attention to these. We need to go back to the designers. And if this is one way that we force everyone in the future to come back and say, hey, will your design actually handle this? Or do we have to reconstruct the whole project? I think insurance companies are going to look at that and say, we're making it safer. We're making everything safer. And I think their premiums eventually would come down because of it. And if we make it safer for the designers, we're making it safer for the contractors. Because if they're not going to be put in hazardous situations, that will reduce their premiums.
Well, it seems like if insurance companies just insisted that certain design steps were followed that prove that they did take these into consideration, then insurance companies could simply say, well, okay, if you don't do this, we'll raise your premiums. If you do it, we won't raise your premiums.
That'd be the logical decision, but unfortunately, there's a lot of them don't think along that line. Well, Eric unmuted himself. I don't know if he has a question or.
Oh, I just wanted to thank you for the presentation. I'm a project manager for Dane County Public Works. I'm also an architect. Very nice, very good summation of all of that. I've also been in a construction accident where I was injured and OSHA shut the job down. So I'm familiar with a lot of those types of things you were talking about. Very good. I mean, it's everywhere. Safety is everywhere. And I work with contractors all the time. You're always looking out for them. There's a lot of new things in the last 10, 15 years, which have increased their safety. I think using mechanical lifts has done that a lot without use of ladders all the time has been, I see that every day. I'll be up on a roof tomorrow. I mean, it's like, it's a constant thing to watch out for. And all of the items you mentioned are very, very important. So.
But since you work for Dane County Public Works, have you been up on the Coliseum roof?
I have not. I have stories about that. We used to have well, I won't name the person, but I've been on the interior where there's, I did a lighting project in there where you're on these on pretty much scaffolding that's running around in catwalks. And there's a little ladder that goes up to the hatch. Yeah. And we used to have a gentleman who would get up there, tie himself off, slide down the outside and clear the snow.
Well, you also had an engineer that went up there with me back when the roof was painted and discolored.
Uh-huh.
That would have been maybe the early 80s. I tied off and used the fall protection cable to go down to the edge, because we had to go down to the edge to see how extensive the discoloration was. He walked the rib all the way down.
Oh boy. Yeah. There's you've got to have the protection. I mean, I was injured when I wasn't wearing a hard hat. I was in college and they didn't have hard hats on the project, and contractor got up on the roof of the building knowing we were under there and unbolted something, and it came right through the ceiling. OSHA shut the job down correctly for 3 days afterwards. But I've been and then wearing the boots that have essentially the ability to stop electricity from coming up through them. That has people, my son was involved with something like that, stepped into a box that was covered with snow. It went down, blew the whole 100 amp circuit, and smoke came up all around him, but he wasn't injured, Yeah. So all those protective devices you mentioned are very important. The tie-offs are a very, very big thing. Most of the contractors we work with are pretty big outfits, and they have their own internal safety programs. But we're always watchful and trying to make sure things go along right.
Hey, you mentioned a hard hat. I was out in Denver, and an engineer had a hard hat sitting on his desk with a screwdriver through it. And I said, I'm just curious, why do you have that on your desk? He says, that's a daily reminder. That's my hard hat, and that's the contractor screwdriver, and I'm not hurt. And he says, up until that point, I was not a firm believer in safety equipment on construction sites.
Well, that'll do it. I had a friend who worked under a bridge when they were doing hot riveting, and they dropped one, and it hit his hard hat and melted a section. It was an older bridge, and they wanted to use those types of rivets still. So yeah, it's a great thing. They're there for a reason, that's why you need to wear them. You need to do the safety, that's I do have a question on you mentioned crime protection through design. Do you have any good examples on that?
That's really coming into play because of what can happen underneath bridges and in tunnels. And if you think of that pedestrian underpass on the Beltline on the west side,
okay,
and not the new one they just put in, the one that, well, they put in maybe 20 years ago or so, where they were actually having assaults occurring in it, and they've had assaults occur in tunnels. They've had cars which would stop cars. They would make it appear like an accident, and cars would stop. And it was dark, so you couldn't see what was happening, and then people would be robbed. And so now we've gone to more lights.
Right.
There's sensing systems in some states. You get out in Colorado, they have sensing systems that'll turn the lights on so they're not on all the time when vehicles go in there, and they'll sense people. And they're keeping a better eye on through other security type systems, but what's happening under some of these big bridges and in some of these tunnels. But that's where this crime prevention really got the impetus is, how do you stop this, or how do you reduce the potential for it? Well, one way is let's make it brighter. Let's have sensors that can sense when somebody's in it or a vehicle's in it.
That's a good example. Yeah. Inside buildings, we've been doing a lot lately, and that's a whole nother venue.
Ever since 9/11, the security systems inside buildings have really taken off.
Right.
And security cameras, the value of security cameras is whether it's for your property or it helps your neighbor's property, aiming them right, making sure you have the right quality, making sure you have the right type of security system inside. The benefits are endless.
Yeah, I'm doing a security project now for a building, and that is about 1/3 of the project is cameras and alarm systems. One of the things we have there is we're utilizing bullet-resistant fiberglass in furniture to like reception desks, that type of thing, just to give you a place to hide down a little bit, and then we're all work out ways to get to a door, so that you can create an exit route for yourself, So we're always looking at that kind of thing. It's you never know what can happen, but you're just trying to make your best. It's a different type of safety, but contractor safety is very important, and most of the ones I work with are following guidelines. You go up on scaffolding. I've been doing a project on the city county building where you're bringing now swing stages, and you're carrying up masonry lifts to check things out for the limestone. That's a whole nother bailiwick. And we recently put a lot of remote drops up there. So you were showing a picture there of having places for painters to tie off and window washers to tie off. That's in the 5,000 pound, you mentioned the 5,000 pound test. So we was running those kinds of tests. OSHA had come or taken a look at the ones we had, and they were inadequate. So we replaced them all. So
Yeah, the OSHA is a good resource, and so is Wisconsin. Both of them are good resources. OSHA has compliance officers that are more than willing to come out and talk to people,
Yeah,
review
It's
what they're doing.
it's not something to be afraid of. I mean, half the time I go on a job, people think, oh, here comes OSHA. You know, no worries, but just do the right thing, you know.
So in
Yeah.
other words, you go out with a hard hat that says OSHA on it?
No, I got my public word, but they just look at me and they figure, you know, you're wearing your vest, you're wearing, you know, you look official, you have like a, you know, name tag around your neck and all that kind of stuff, you know. And so, you know, people think, you know, you're just always watching out. It's all right, but it's a great thing, but the profession has a real need for the safety aspect. That's paramount for both the contractors and the public. So it's a major thing. So that was a great presentation. I really liked the slides.
Thank you much, Eric.
Yeah, great stuff.
Very good. Well, thank you, Norm. That was terrific. And thank you everyone for joining us tonight. We've made a recording and we'll talk to Norm about what we can do with it. But maybe we'll put it up.
You gonna post it?
If we can figure out if it's okay with Norm.
Well, we will be posting the videos that we've done. I've already put the one that